All right, so I will be introducing another concept in physics about work and energy. This is a perfect video for learners, especially our grade 8 learners who want to, you know, pass their exam or review for their upcoming exam or long test about work and energy. And of course, it is also good for teachers who are teaching work to their learners because this is one of the competencies taught in grade 8. Okay. And these two words are interchangeable, somewhat related, but there is really a difference between these two words. So we will try to find out on this video. We will define first energy. Energy is very famous for its definition, ability to perform work. And work is being introduced by the definition of energy. Energy has the capability of doing work to object. Also put it this way that energy causes work, right? Work to object. Mhm. And don't forget that energy is possessed by an object. Either the object is resting or the object is moving. As we all know, resting, no velocity, that's going to be potential energy present there. In moving object, of course, we have kinetic energy. So this potential energy, energy at rest, or kinetic energy, energy in motion, helps in doing work. Energy is the ability to do work possessed by object, either resting or moving. This energy could be able to make work to happen. Work is not about profession like a teacher, an engineer, or like a PMA or nurse, okay, or soldier. Work in physics, it has something to do with these two variables. Work is defined as the product of force and displacement. So we have two important or crucial variables in calculating work. We have force and displacement. We will review first the individual definition of force and displacement. Force is the pulling and pushing mechanism. Push and pull. That's force. Okay. And it's a vector. Remember vector? Vector has magnitude and direction. Let's say the force is 3 newtons. That's the unit of force. 3 newtons right, meaning the force is acting to the right. And the amount of force or the magnitude of force is 3 newtons. And we will have displacement. Okay, displacement is also a vector. So it has magnitude and direction. Same with force. Okay. Example, 1 meter north. So we have 1 meter as our magnitude or value. We have north as our direction. It is also defined as the change in position. We have a ball on the ground and then we have a force. Force is represented by arrows. That's the force being applied to the ball. And once there's a force, like you push the ball will begin to accelerate. Remember, force causes acceleration. So when you apply force to the ball will move or accelerate. So we can have a change in position. So the starting point, we call it the initial displacement, and then the final position of the ball after some force being applied is our final displacement. D sub I is our initial displacement, starting point, and then F there, D sub F is the final displacement. So we have a change in position because of force. So that's work. When there is force applied to the object, and then the object moves or accelerates or in position, that's definitely work in physics. When there will be force and then the object moves, there is work. So to make the story short, no work, we can say that no work if no motion. It's very true. No work when there will be no motion. When you apply certain force to the object and the object doesn't move, so no work is done. When there will be motion because of force, yeah, 100% work is there. Okay, another thing to know about work is a scalar quantity. It might be confusing because we are dealing with vectors here, like with direction, right? Uh, Force is a vector, and we have displacement, a vector. But when you multiply it, there's a concept called the dot method, or when we multiply vectors, okay, it will result to a scalar quantity, meaning direction is insignificant. We never consider direction when we are uh, calculating work, okay? There's no work to the left or work upward or work downward because work is a scalar quantity. So we will focus mainly on magnitude or the value. So talking about work, what's the unit of work? So since it's a product, look at the very first definition we had. Product of force and displacement. When we say product, it's just the answer of multiplication. So we have to multiply force, multiply to displacement. Okay, what's the unit of force? Unit of force, if you could still recall, we have 3N here, and N is the unit of force. We call it Newton or uppercase N. Force, that's Newton, and then we will multiply it by the unit of displacement. What's the unit of displacement? Since we're dealing with position, let's say the initial position of the ball is here, and then this is going to be the final position. And if we will measure it, let's say it's 2 meters. So the unit of displacement is this one, meter or lowercase m. So we will multiply Newton and meter. The unit will become Newton meter. That's the unit of work. Another way to write Newton, if you could still recall, 1 Newton is equivalent to 1 kilogram meter per second squared, because you will just multiply mass and the acceleration. So you will have kilogram meter per second squared equals 1 Newton. So we can also multiply it in that way. So we will multiply 1 Newton. You can also write it as 1 kilogram meter per second squared. They are just the same. These are units of work. So we will multiply kilogram meter per second squared times the unit of displacement, which is meter. So meter times meter, that's meter squared. And then it's understood that we have over 1 here. So second squared times 1, that's second squared. And then we have kilogram. We will just multiply kilogram to meter squared to second squared. Are you familiar with this unit? It's also called joule or caps lock, or yeah, uppercase J. And remember, joule is unit of energy. Since work is just like we need energy to do work, so the unit of work is also energy. We will be calculating work in our future topic. You can write it this way. You can have unit such as uh, Newton meter or kilogram meter squared second squared or joule. These units are units of work. So it's up to you what to use when you are calculating work. Now we will try to define another definition. I will erase some of the parts here. So always remember, work is just the product of force and displacement. So we can mathematically express work. The formula of work is very simple. Work, we will be using that symbol, caps lock W. That's work is equal to force times displacement. Okay, we will be knowing more of it in our next video, but this time we will be dealing with work first. It's a process of transferring energy due to force acting on an object and causes displacement. So we can say that there's work. Work is done if we will go back to this definition. When there is a transfer of energy due to force, and then that force is acted to the object, and then the object moved from one point to another. Meaning to say, there's work or work is done when energy is transferred to the object because of the force transfers the energy to the object, and then that object moves at one point to another, or it has displacement, like what I have showed a while ago about the ball. And we have force applied to the ball represented by the arrow. It's going to the right, and of course the ball will move or accelerate following the direction of the force, so it's still going to the right. There's a displacement. We have initial displacement and we have final displacement. Let's say we have 2 meters here. That's the displacement. Look at the direction of the force. The force is going right, and then that force causes the object to move, or to move from one point to another, or displacement following the direction of the force. Work is definitely in that scenario. So I hope it makes sense, right?